All right, so question 66. A list of consecutive integers begins with m and ends with n. If n minus m is equal to 66, how many integers are in the list? Now, this is kind of more of a conceptual thing, to be honest. A lot of people will tell you to use formulas, but I feel like the best way is just to understand what this means. So we're saying the difference between the greatest number and the smallest number is 66. Now, when you're given the difference between the greatest and least numbers, as long as the numbers are consecutive, you can just say that the number of numbers in the set is just the difference plus 1. That's just the number of numbers. And just to help you better understand that, we're going to work with a set here that's a lot smaller than, 67 numbers. 67 numbers, sorry. 1, 2, 3, 4, 5. So the difference between the greatest and smallest numbers here are 5 minus 1, which is 4, right? So it can't be 4, though. We don't have 4 numbers in this set. We have 5. 1, 2, 3, 4, 5. We have 5 numbers in this set. So really we have one more than the difference. So 4 plus 1 is equal to 5, right? So similarly here, we're finding that the difference is 66. So the number of numbers must be 67. That is something that I would try to memorize. This rule does get a bit complicated. It might get a bit complicated in your head when you have, for example, consecutive integers that aren't like, for example, consecutive even integers or consecutive odd integers. Then it could be a little bit strange to you, but just remember this formula whenever you have a problem like this with consecutive integers. Next, we have 67. Here we are told to simplify the expression. So first what I want to do, because I notice this is a complex fraction, where we have a fraction in a fraction, and I want to try to get rid of that. So immediately what I see here is that we are dividing 39 times this parentheses over 3. We're multiplying, yeah. So we are multiplying this by 39 dividing by 3. So what I want to do here actually is first simplify this by turning this into 13 and just canceling this out. What I'm basically doing is just dividing 39 divided by 3, and that is equal to 13. So I can now rewrite this as 13x minus 3. There's no over 3 because we just got rid of that, silly me. Plus 39 over 13. Now this steps here seem a bit more obvious, hopefully. What I'm going to do is I'm going to distribute using the distributive property that we learned about. 13x minus 39 plus 39 over 13. I'm going to put the equal signs here just to show you we're not changing the actual value of the expression. We're still maintaining what it says. Now, the obvious is here that we're going to subtract 39 from 39, or rather add 39 to negative 39, and that is equal to 0. So these two kind of cancel out in a way. So we're left with 13x over 13. And last but not least, the obvious here, you're just canceling out the 13s, and you're left with x. Just like that, A is your answer. And we can check over here. Yep, A is your answer right here. All right, cool. Next, question 68. Jar 1 and jar 2 each contain 1/2 cup of water. If 1/4, I'm going to circle all these numbers here. If 1/4 of the water in jar 1 is poured into jar 2, how much water now is in jar 2? So we're going to visualize this. I think that's the best way to go about this. Obviously, you might not want to draw this on the actual exam because you're not going to have time, but just so you understand, we're going to do it here. So both of these jars, so this is jar 1 and this is jar 2. Both of these jars have 1/2 cup of water, right? And what I'm doing is I'm taking 1/4 of the water in jar 1 and adding it to jar 2. So to find the value, find whatever is 1/4 of the water in jar 1, we can either do 1/2 times 1 over 4, which would lead us to 1 over 8, or we can just divide 1/2 divided by 4, which will also lead us to 1 over 8. What this basically means is that since 1/4 of the water in jar 1 is 1/8 cup of water, we're going to add 1/8 cup of water to the amount we have in jar 2. So 1/2 plus 1/8. And as you know, we have to make sure that when we add fractions, they have the same denominator. So we're going to turn this into 4 over 8 plus 1 over 8, which is equal to 5 over 8. And just like that, we have the amount of water in jar 2. We can check our answer once again right here. We got answer choice G. One thing, if you want to try to find the amount of water that is in jar 1 now, after we have moved 1/8 cup, all you got to do is just do 1/2 minus 1/8. That's 4/8 minus 1/8. That's 3/8. So notice how the sum of these two is equal to the sum of these two. So 1/2 plus 1/2 is equal to 1, and 3/8 plus 5/8 is equal to 1. That makes sense because we're not just mysteriously adding water out of nowhere. We're taking water from one cup, or one jar rather, and putting it into the other jar. And last but not least, we have question 69. If n is a whole number, and 0.01 is between n and n plus 2, what is the value of n? So, one thing to note here is that 0.01 is equal to 1 over 100. And that makes sense because when we read this out loud, we say 1/100th. 1 over 100. So what we're basically saying here is that 0.01 is between 1 over n and 1 over n plus 2. So what this basically could mean, because here we're saying that 1 over 100 is equal to 0.01, n will be equal to 99 here. And n plus 2 is equal to 101. So basically what we're saying here is that, sorry if I said that a lot, but what we're saying is that 0.01 falls between these two values. And once again, because we're being asked to find the value of n, 99 is our answer. Now, I feel like this problem, I wouldn't personally use like any sort of algebra, any sort of actual math here. I think it's just a matter of realizing that 0.01 is 1 over 100. And when you have, actually, for example, when you have like 1/2 and 1/4, this means that 1/3 is between these two numbers. Because this is 0.5, this is 0.25, and if you know what 1/3 is, that's equal to around 0.33. And that's just kind of a rule that exists in math, to be honest. So here, for example, 1 over 100, that's going to be in between 1 over 99 and 1 over 101, with the same exact logic as what I just explained. Yeah, that's pretty much what I would at least do if I were solving this problem.